Today presentation outlines are introduction to KNN, types of problem solved, need for KNN, working principles of KNN, advantages and disadvantages and applications of KNN, conclusion. Introduction to KNN. K nearest neighbor or KNN is a supervised learning algorithm, meaning it learns from labeled data. KNN works on a simple idea. A data point is classified based on how its nearest neighbors are classified. So it predicts the output of a new data point by looking at the K closest data points around it. It is mainly used for classification where we assign categories and regression where we predict numerical values. One of the biggest advantage of KNN is its simplicity and intuitive approach, which makes a good starting point for understanding machine learning. Types of problems solved by KNN. KNN can handle two types of problems. First, classification, where the output is category or labeled. For example, identifying whether an email is a spam or not. Second one is regression, where the output is continuous value such as predicting house prices. So this dual capability makes KNN a flexible algorithm. Next, why do we need KNN? KNN is important because it follows a very natural concept of similarity. Instead of building a complex model, it simply compares a new data points with existing one. For example, if you have fruits like tomatoes and bananas, we can classify them based on the features such as color, size, shape, etc. When a new fruit is introduced, KNN checks which existing fruits it is most similar to and classifies it accordingly. Take the majority of vote. For regression, calculate the average values for data points. The simple process helps us make predictions effectively. So this graph shows that this is the new, suppose this is the new point, means we can find the K value which is nearest, then we can, based on that we can classify data into different categories. So this slide shows that how we classify the data. Suppose this is the data set, this is the new data point to classify the data set. So from this, what are the K values? We can, based on the K value, we can find the distance between that. Then we can classify the different categories. For this given example, there are two different classifications. One is class A, another one is class B. So suppose if the K means find the distance. Which are, for example, this is the distance between the data points. So here suppose 3, here the 4 values are nearest. So based on the K value, we can classify the data set. Which are, suppose the K value is 1 means data is, this is close to UV data. So based on this distance, this is shortest distance. We can select the shortest distance data point. So in this way, you can classify the data category. So this slide shows that how we choose the number of neighbors. For example, k equal to 5. How we select a k equal to 5? So for that we can find the distance between the data points. For that we can use the distance metric. The most commonly used metric is Euclidean distance metric. So here we can use the formula for that. So this is the formula to find the distance between the data points, and that formula is x2 minus x1 whole square plus y2 minus y1 whole square. Then take the square root. So suppose that there are 2 points A and B, we can find the distance between them. So like that, we can find the distance between that all the data points which are close to. Then we select the shortest distance. Based on that, we can classify the data. So from this example, for this data set, for this category K equal to 3. So this is the nearest, this is data point. This is the nearest distance. So for this category, K equal to 2. So this is the nearest distance. So if you take this data point with compared to these three values, so this value is more distance. That's why we can omit this. So here they are checking the similarity between each other. So what is the distance between these two groups? This is these two groups. So both differences are same. Then we can classify the data into different categories. So based on this majority voting, the new data point is classified as the category A and category B. So this shows how KNN make decisions based on the nearby data. So this slide talks about the regression. In regression problems, the approach is slightly different. Instead of voting, you calculate the average value of the K. So the classification gives discrete output. Regression gives continuous outputs. However, in both cases, distance calculations plays an important role. So this slide shows an example. Let us take a simple real life example. Suppose if you want to classify a fruit as apple and orange, we can select the k value. Suppose k equal to 3. Then k equal to 2 means uh, nearest these are nearest as apple. K equal to 1 means nearest neighbor is orange. So we assume the value for k. So which is closest to that k means 2. So that way this is the apple. So next distance is called as k equal to 1 means that is known as 2. So the majority of voting is 2. So that's why it is category apple. Then remaining next closest level is plus into another category, that is orange. So the new fruit is classified as the apple because the apple is having the majority of voting. So that's why the new fruit is classified as apple instead of orange. To measure similarity, KNN uses different distance metrics such as Euclidean distance, which measures straight line distance. This is a commonly used method. Next one is Manhattan distance, which measures grid-based distance. Third one, Minkowski distance, which is used as a generalized form. So among these, Euclidean distance is the most commonly used in practice. The formula to find the distance between 2 points is square root of the distance d, which is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Suppose if you have point 1, this is another point. To find the distance between these 2 points, suppose this is the point A, this is the point B. To find the distance between these 2 points, we use this formula. So this formula helps us calculate the distance between two data points in space. It measures how close or far two data points are. It is essential for identifying nearest neighbor. With the help of this formula, we can find nearest neighbors, that is k value. Choosing the correct value of k is very important for model performance. A small k may lead to overfitting as it is sensitive to noise. A large k may lead to underfitting as it smooths out the data too much. So we usually choose odd values like 3, 5, 7 is a common practice for classification, and also we use cross validation to find the best k value. From this example, suppose this is the new data point to find the distance between the values. So these are the distance. So this is the distance. Suppose these are the distance. Suppose k equal to suppose k equal to 1 means sorry what k equal to 3. Suppose k equal to 3 means so this is the data point. These are the best fit. So these are the more distance. So under fit. This is a small distance. So this is the overfitting. In this way, we classify the data set in different category. So the newly added data, this belongs to which class? This is identified with the help of k value. So it measures how close or far data points are. It is essential for identifying nearest neighbor. So using Euclidean distance, calculate the distance between two points in space. Sorry, this is the real world application. KNN is widely used in many real world applications such as recommendation systems like suggesting movies, image recognition, medical diagnosis, and predict scoring in banking. These applications show its practical importance. So to conclude, KNN is a simple yet powerful algorithm that works on the concept of similarity. Although it has some limitations, its easy of understanding and implementation makes it very popular in machine learning. Thank you for your attention. I hope this presentation gave you a clear understanding of the KNN algorithm.